All right, ladies and gentlemen. So I did want to go over the formative you guys took. I believe it was last week on Thursday. You guys took a formative on covalent bonds. I wanted to go through that with everybody. So if you guys want to open it up or just watch the screen, it is going to be shared on the screen. So the first thing you guys have were four multiple choice questions. I'm not going to go through the wrong answers, but number one, it says what is a polar covalent bond? And that's an unequal share or distribution of a shared pair of electrons due to an electronegativity difference or large electronegativity difference. So for number one, we were looking for some electronegativity. The difference in electronegativity creates an unequal share pair of electrons, which causes it to be a polar covalent bond. For number two is PCl bond. What type of bond is it? And it's going to be polar covalent because it lies between 0.5 and 1.7 with the electronegativity difference. Number three, what type of bond is the weakest covalent bond? And it's going to be our single bond is the weakest covalent bond. That's because there's only one pair of electrons or two electrons being shared, so there's not much pull, so it's easily broken apart. If we add more electrons, so two from each atom, it's going to be a little bit stronger. And if we add three from each electron, it's going to be even stronger because they're being pulled closer together. And then number four, in a covalent bond, the electrons are going to be shared. And then ionic bonds, if you were doing those, that's when the electrons get transferred. The next half of the questions we were looking for was for you to name the compound, identify polar or nonpolar by showing your work and doing your electronegativity difference calculations. And lastly, coming up with the Lewis dot structures for those compounds. So the name here is going to be carbon, since there's just one of these elements. So it's carbon. And then there's four hydrogens, which means it's going to be tetra for four. And then hydrogen turns into hydride. So carbon, tetrahydride. That first one. If we do our polarity difference or electronegativity difference, we find out that carbon has an electronegativity of 2.55 minus hydrogens, because it's a carbon-hydrogen bond, which has an electronegativity of 2.20. And if we take the difference, we get 0.35, which is under 0.5, which makes this a nonpolar bond. When we're drawing that Lewis dot structure, we draw our elements, so carbon and our hydrogens. We have the two options here. We can add up those electrons and figure out how many bonds we need to create, or you can circle between the two different elements. It is up to you which one works best. We should remember that carbon needs a total of 8 valence electrons, and hydrogen needs a total of 2 valence electrons being shared. Once we draw those bonds, we can see that carbon will have 4 bonds, 1 to each hydrogen atom. Any questions? All right, I'm not going to go into too much of the calculations and stuff now, but you should have gotten carbon dioxide here. And then when you do your calculation, you have 3.44 minus 2.55 to get 0.89, or a polar bond. When you draw this one out, the big thing here, when you guys drew this one out, is we identified that carbon had 2 double bonds to both oxygens. And then we have to put lone pairs back on the oxygens only. So the big issues I saw with this one were that we were putting lone pairs on carbon, we weren't making double bonds, or we weren't bringing those lone pairs back onto oxygen. I think number 7 was probably the trickiest one, because we have to remember that oxygen is a diatomic. And what a diatomic is that it will never be found alone. So when I give you the name oxygen, I'm looking for O2. So the formula O2. When we do that electronegativity difference, we will get 0 because it's the same number twice, which means it's a nonpolar bond. And when we draw that Lewis dot structure, again, there is a double bond between my oxygens because each one wants to create 2 bonds. And we need to bring those 2 pairs of lone pairs back onto our oxygen atom. Last but not least, we have nitrogen trioxide or trihydride. Which is going to be 3.04 minus the 2.20, which gives us 0.84 or a polar bond again. And when we draw this Lewis dot structure, you should have gotten nitrogen with 3 bonds, 1 to each hydrogen, bringing back the 2 lone pairs onto our nitrogen. Are there any questions on any of those problems? All right, then today what we're going to be doing is we are going to be doing some practice with ionic versus covalent bonds, drawing, naming, everything combined. So I want to go over a couple things before we go through this. Oh, maybe not at the bottom. I'll just do it at the top. Ionic versus covalent. So I want to know, just in general, what do we remember about ionic versus covalent bonds? Who could tell me something that we have to do for ionic or covalent bonds for naming, drawing, identification? What's one thing we know about ionic or one thing we know about covalent bonds?
Covalent is nonmetal with nonmetal, and ionic is metal with nonmetal.
All right. Perfect. Covalent's 2 nonmetals. Ionic is a nonmetal and a metal. What else do we know about these?
Ionic transfers electrons, and covalent they share electrons.
Awesome. Anything else we know about them in general, or about maybe their drawing, or about their naming, or about their formula writing, any of those things? Let's talk specifically about naming. So we're talking about naming here. So naming. For ionic and covalent bonds. What's one thing in ionic or covalent bonds that we have to do when we name an element? Or name a compound.
You don't add prefixes to ionic compounds.
No prefixes. All right. What else? Should have given you a hint for what you have to do in covalent bonds.
Prefixes and suffixes for covalent.
All right. And what's the suffix going to be?
Ide.
All right. Do we need a suffix in ionic?
Yeah.
Yes. For the second element in both, we do need a suffix. Anything else we need to do for either of them or both of them? I would say there's at least one more thing for ionic. Anybody have any ideas?
Polarity? Polar?
Not polarity, so that's going to be for covalent more than ionic.
Metal first.
Metal first, perfect. And what's one more thing we have to worry about with metals, or specific type of metals we have to worry about?
Transition metals.
Transition metals. Why do we have to worry about transition metals? What could we have to add with transition metals?
The groups at the top don't define the valence electrons.
Perfect. Number of valence electrons. Represented by what?
Roman numerals.
Roman numerals. Perfect. All right, I think that's everything that we need to remember in order to name our ionic and covalent, or just in general with our drawing of ionic or covalent, or just identification of ionic versus covalent. Do you guys have any questions about any of it? All right, if you guys have no questions, then what you guys are doing today is finishing up this worksheet on ionic versus covalent bonds. You are doing all of it. Tomorrow you do have another formative on both ionic and covalent bonds with naming and drawing.